We set it equal to a variable, rewrote it as an exponential function. 5 to the x equals 5 squared. So when they're the same base, x equals 2. So log base 5 of 25 is 2. Doing the same thing on each of these. Let's see, that was to the 5th power? 4th? So x equals 4. And what do we get on 3? Negative 3. And what do we get on 4? 0. All right. Pretty easy when we can come up with them to the same base. Problem is, what happens if it's not solvable? Well, 10 squared is 100. 10 to the third is 1,000. So we know it's going to be 10 to the 2 point something. Do we really want to keep trying to gum up with those decimals to get as close as possible to 142? Not really. Because if I'm asking that, there's probably a way that we can work this out. Okay? So what happens is we can rewrite our logarithms using any base we want. Okay? Change of base. What that means, and usually we're going to write them using just a regular logarithm, because on any scientific calculator you have a button with log on it. That is already programmed to be log base 10. So instead of rewriting it as an exponential function, which in this case is not solvable, unless you just really, really want to try to find that decimal number, we take this and we rewrite it to the following. Log of 142 divided by the log of 10. So the logarithm of divided by the log of the base. So what do you get in your calculator with that? I will caution you, when you do these, you have parentheses that go around the number. Make sure you close the parentheses. Log of 142, close that parentheses before you tell it to divide. And when we do these, we typically round it to the nearest 10,000. So approximately, since it's not an exact number anymore, it's rounded. So what that means, and we can check it, is 10 to the 2.1523 should get us pretty close to 142. going to be exact because again, you rounded it off, so it's not exact anymore. Okay, so this even works in the previous one we just did. It'll work all the time. Just like the quadratic formula works to solve any quadratic equation, even those that are factorable. So if we were to do number 1 this way, log base 5 of 25 in our calculator will be log of 25 divided by the log of 5. And you should get 2. So regardless of whether it can be solved using exponential equations or not possible because there's no way to get the bases the same, change of base will work no matter what. So let's take a look at these. So your change of base formula. So if we have log base b of a, that means it's the log of a over the log of b. Change of base says we can make this any base we want. So I certainly can do log base 2 of a over log base 2 of b. But I'm still in the same problem because my calculator will not calculate log of any other base. So what we're trying to do is find something our calculator will do. And common logarithms, which is the log on your calculator, that's usually what we change it to. So, this one, log of 16 over log of 3. So approximately 2.5237. So 3 to the 2.5237 is about 16. Number 6, log of 0.4 over log of 5. And negative 0.5693. Number 7, log of 2 over log of 3. Couple ways we can write the common logarithm in your calculator. A number, one's like number 8. I can move the exponent of 4 in front and type it in like this. Or log of 5 to the 4th, which your calculator will give you is 625. Or log as 5 to the 4th power divided by log of 6. It will come out to the same answer.
Do you put the 4 in the parentheses or not?
You can.
Okay.
Yes, I would. So we get approximately 3.5930. It's 5929 followed by 7. So these you will lose points if they are not rounded correctly. And as we go through the rest of our work today, you're going to want to make sure to completely don't start rounding. Keep the answers going in your calculator. See what you can do with the next row. These. Write it again. Okay. So. Again, you can always write that. Like that. So in your calculator, you would type in 5 log 4 and close parentheses after that. So, interesting. So we get approximately 3 points, and the 3's just keep going. Yeah. Okay, so 10. We get approximately 9.5098. It's tricky when you're exponents. Okay. What will happen if you write it like I've got the others? Well, 1/2 goes in front of the log of 150, which means writing it correctly, because we don't write fractions over fractions, it actually ends up going here. Because it's 1/2 log of 50, which puts the 2 in the denominator.
I didn't get the same thing for 10.
For 10?
Yeah, I got it.
I got 11.0882.
Hold on.
Yeah. And on number 9, I got
Divided by. Oh, yeah. Sorry. I probably had 5 or something in front. 8. We get on 9.
That's what I'm
Okay. Very easy with all the numbers to type in something off. So we get 0.5191. Good? No?
I got 1.404.
I got 2 points.
I got 2. I got 2.2.
I got
I got 2.3. No, I put it in with the. I put it in with the radical. Under the radical.
That's what I did too.
Okay.
I didn't. I was just taking it out.
I
We put it in.
put
So.
it in number and it's probably stick on you.
So, really lots of places with these exponents, so really just watching where we've got our numbers. Again, easiest to just not shift a lot around. Watch your exponents. That's going to be the tricky part. 8809? Okay. Okay. Again, changing them out gives you a way to evaluate logarithms that do not do this. So, I want you to solve the first two equations on the next part. However, what if when we get to problems like 15, we can't do that? So I can do anything I want to equations and inequalities as long as what I do to one side I do to the other, correct? So on 13, to both sides. And using my properties of logarithms. Now granted, is that the easiest way to work this problem out? Probably not. Considering I can go on ahead and write that as 2 squared 3x minus 3 equals 2 to the third 4x minus 4. So if you see the easy way to get them to the same bases, that's still going to be your easier option, especially if it involves something like this. So then we've got 6x minus 6 equals 12x minus 12. So we've got negative 6x when we subtract the 12x equals negative 6. Did we get x equals 1?
Yes.
Okay. And we'll take a look at ones like 13. But again, it's a route you take when you have no other option. Okay. So just like 14, we can get them both to a base of 3. Three to the third. 6x minus 10. So we've got negative 2x plus 10 equals 18x minus 30. Subtract the 18, negative 20x, subtract the 10, x is 2. Okay, so 15. Is there any way to rewrite 12 so that it's a base of 3? 3 to some power. Now without a lot of guessing. So this is where we want to go back to do something to both sides, but make sure it's the same. So apply the logarithm to both sides. So you can apply anything you want to both sides. It's an equation. But whatever you do, it has to be balanced. So if you've got anything out as exponents in these, you want to bring those exponents out to the front. So we've got 2x plus 1 times log of 3 equals log of 12. You want to solve for x. Remove anything like normal. So we want to divide both sides by log 3. So log of 12 divided by log of 3, which puts it in the change of base format. So this is where I want to caution you to make sure you're not rounding. Okay? So in your calculator, figure out what log of 12 divided by log of 3 is. Then from that answer, subtract the 1. Then from that answer, divide by 2. Trying not to cut off and round it until you get to the very final. So this is the math. So that's the math that's going to go on in your calculator. So most scientific calculators, my recommendation, find your log of 12 divided by log of 3. Subtract 1 from that answer, then divide by 2. And then just keep using that previous answer so it doesn't get rounded until here. What'll happen if you round it and cut it early is you will have minor differences with usually those last 2 digits. Okay. So what this is saying is 3 to the 2 times 0.6309 plus 1 is 12. So pretty close to 12. Okay. So change of base works with this. So it puts it in that format to do it, and then continue solving for x. So if we look at the next one, again, no way that we are going to get 4 and 12 to be the same base. So apply the log to both sides. Any exponent, rewrite it so it's in front. Divide what logarithm you have so that we can get at x. And then what you'll end up doing once you find the log of 12 divided by the log of 4, you will divide all of that by 3. So one thing I want to look at on 16, you can apply the logarithm to both sides. And it gets you to the change of base. The other way, because one thing we've always said, to solve an exponential equation, we can rewrite it as a logarithm, right? So if I were to rewrite this as a logarithm, 3x equals log base 4 of 12. Well, what I know about change of base, log base 4 of 12 can be rewritten as log of 12 over log of 4, which is that part right there. So it will come out either way. Rewrite it as a logarithm, apply the change of base formula, or take the log of both sides, use the logarithm property to get the exponent out of it, and it gets you to the change of base, either way. So 17, bring the exponent out front, which starts getting it into the change of base format. Move log of 3.6 over so that I have 4x minus 1 So before I finish solving this, I will end up adding 1 to that and dividing by 4. And then dividing by 4. And we get approximately . The mistakes will happen is if you forget to close the parentheses around this first part, the 85.4 on your calculator. And so as we're doing these, again, keep in mind, if I rewrite that as a logarithm, log base 7 of 21, log base 7 of 21 is not, we can't calculate that easily, so we change it out to change of base. If you applied the logarithm to both sides, you should have gotten to that point as well. So it sets it up either way. You're writing it as a logarithm, change your base, or take the log of both sides, and it gets you there anyway. So whichever way is most comfortable for you, what makes most sense to you to go about that, because you won't be graded on one or the other. All right, so in this one, we would add the 1, and then we're going to divide by 3. Again, keep in mind, it doesn't matter what our numbers come out because our original problems are exponential function, equations or inequalities. Those can be anything. It's just we're using logarithms to help get to our answer. So this one, it just needs to get at x, so I probably would just rewrite it as a logarithm and then change the basis just right there. So that gives us approximately 3.357 feet. $20, either way will work. So if we go with log of 9 to the 2x is less than log of 120. Bring the 2x out front. Log of 120, divide. So it still gets us to that log base 9 of 120. So then we'll end up, once we figure this, divide both sides by 2. So x is less than 1.0894. Okay, 21. Do we need logarithms? No, we do not. Will it hurt to do them? No, not really. Let's see. Okay. So keeping in mind with change of base, log of 16 divided by the log of 4. Regardless of whether you got them to the same base or not, that's still going to give you 2. Log of 16 over log of 4 should still be 2. Add 3 to both sides, and that gives us 5. So typically, once we take the square root of both sides, we leave it as a radical plus or minus 5. That's the exact answer. Now what you'll have on these is round to the nearest 10,000. So those 4 decimal places. So this one gives you a nice answer. However, you can also leave it as let's see, 2.2361. So on 21, since we were neatly able to get to the square root of 5, I would still take that as an answer, because that's exact. Or if you gave me the decimal, that's fine too. Okay, so we are going to take a look at the last ones at the beginning of class next time. Because they, with having exponents on both sides, it's like the one I started at the beginning of your notes. So